Hello, this is Miss Goodwin, and this is Objective 4.2.1, the Pythagorean Theorem. This is the first of 3 lessons in Objective 4.2, where we start using the concepts in 4.1, sine, cosine, tangent, to figure out sides and angles of right triangles. So the objective for today is that I can use the Pythagorean Theorem to calculate the missing side of a right triangle. So let's go ahead and get started. So let's take a look back at these right triangles and look at our sides. So we're using angle A as our reference angle. We know that the longest side right here is our hypotenuse. The other 2 sides are our opposite and adjacent sides. Those are also referred to as legs. So the legs come off this right angle here. Now, there is a ratio between the square of both the legs summed together and the hypotenuse. This is called the Pythagorean theorem. So if we take the square of one of the legs and add it to the square of the other leg, that equals the square of the hypotenuse. If we were to assign variables to the sides, like this is A, this is B, and this is C, we can also rewrite our Pythagorean theorem as A squared plus B squared equals C squared. So A and B correspond to the legs of the triangle, and C is the hypotenuse. Now I'll go ahead and link a video in the description below that goes through a proof of this in case you would like some more background information. But in this video, I'm just going to show you how to use the Pythagorean theorem to solve for a side of a right triangle. So now let's look at our first example. Now I have our right triangle with a side length of 3 and 4, and then our hypotenuse is C. So 3 and 4 are our legs. So I'm going to go ahead and plug those in for A and B. Let's do 3 is A and 4 is B. Doesn't really matter which one is which. But let's go ahead and plug those in. And now we have to simplify and solve for C. So I can see here 3 squared is the same as 3 times 3, which is 9, plus 4 squared, which is 4 times 4, which is 16, is equal to C squared equals to C squared. And now we have 9 plus 16, which equals 25. Now, to get rid of this square, I have to take the square root of both sides. So let's take the square root of C and the square root of 25. Square root of 25 is 5. And square root of C squared is just C. And that is all we have to do. So we have figured out the hypotenuse of our right triangle. Now, let's look at an example where we have the hypotenuse in one of the legs, but we need to find another leg. So now we have a right triangle. We are given the hypotenuse of 13 and one of the sides, which is 12, and we are looking for this A, the length of that leg right here. So I'm going to label 12 as B and the hypotenuse is C. Hypotenuse always uses C. So let's go ahead and plug in our numbers. We still don't know what a is, so we're going to leave that. B squared, we know b is 12, so I'm going to replace the b with a 12 and square that, equals our hypotenuse, which is 13, and square that. And now we use our order of operations to simplify like before. So a squared is still a squared. 12 squared is 144 equals 13 squared, which is 169. Now I have a squared plus 144 equals 169. I want to get a squared alone. So I have to get rid of the 149 by doing the opposite. So the opposite of plus 149 is minus, I'm saying 149, I mean 144. The opposite of plus 144 is minus 144. And what you do to one side, you have to do to the other. This cancels out 144 on the left. We're left with a squared equals 25, which we could take the square root of, and that leaves us with a squared, no, just a equals 5. So we know a equals 5, and we are done. So that's it for this video. If you have any questions, please go ahead, let me know in class or through email or through Canvas. Go ahead, get started on the rest of the playlist now, and I'll see you in the next video. Bye!